Hello everyone and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper, Charlie to friends, and I'm a theoretical physicist currently doing a postdoc over in the University of Helsinki in the Helsinki Institute of Physics in Helsinki, Finland. And I'm a cosmologist, which means that I study the universe, the contents of the universe, how things evolve, how things interact, cool stuff happening inside the universe. I love being a scientist, I love being a cosmologist, and I love chatting to everyone about all of the cool things I get to work on. So for anyone who doesn't yet know, Cup of Cosmology is an interactive stream. As you can tell by the technical gremlins that I had at the beginning today. Apologies if you saw me appear and disappear. The stream just wasn't loading for me, but I got it working now. So anyway, this is an interactive stream. So the idea here is that you people can ask me anything you want about space, about cosmology, about physics, about life in Finland, about myself, about my cat. It really is a general ask me anything. I might not have all of the answers, but I will do my best to answer the questions that I do know the answer to or that I can somewhat figure out the answer to. I see we have a lot of the regulars coming in here. We have Anne, Scott, Paul, Prath, David, Howden. Great to see you all. Great to see everyone here, as always. Welcome back to all the regulars. Welcome if you're a first-time viewer. If you haven't done so yet, please do subscribe to the channel, like the video, leave a comment, do all of the usual YouTube stuff. YouTube things. It really does help if you press buttons and make stuff happen. It really does help boost engagement, as you can see. My cat will be slightly disruptive today. One just walked past the screen and is now sat on my laptop, which is exactly why my laptop needs to be closed at all times. It kind of defeats the point of having a two-screen setup if I have to close one so the cat can sit on it, but that's okay. He's very cute. So yeah, I know Cup of Cosmology has been a bit intermittent the last couple of months. I'll be back today. Next week I'm off again because it's Easter. I should be back then the following Sunday. I don't think I have anything on the 27th. To my knowledge. Anyway, yes, Cup of Cosmology has been a bit intermittent over the last few weeks and months, mainly because I've just been doing a lot of stuff, and often Sundays is the only day I can actually rest. But anyway, back today. Hey, Takina, great to see you as always. Thank you for popping by and saying hi. Great to have some locals here as well. Okay, so welcome everybody. Welcome back to regulars. Welcome if you're a first-time viewer. I do not have a topic prepared today, which means it is up to you, the audience, to decide what we get to talk about. This means that your questions will dictate the direction of this stream. You can ask me anything you want, and based on your questions, we will figure out what we're talking about today. If you don't have questions, I get to monologue about my favorite things in the universe, which some of you will already know what that entails. But in any case, let me catch up with comments and then we can figure out what we are actually talking about today. See, greetings from all of the regulars, always very nice. Coming from David Howden. Been a while since I've caught one of these. Yeah, indeed, I have been very, very intermittently online. How is the universe these days? Still there. Fortunately, the universe has not disappeared overnight. We have not reached the heat death of the universe. The universe has not, to our knowledge, yet experienced vacuum decay, although it might at some point. Just saying, might happen. vacuum decay is something that could happen, and the universe could blink out of existence just like that. But that, to our knowledge, that hasn't happened yet. So yeah, the universe is still here. We are still trying to figure things out in the universe. We haven't solved all of cosmology just yet. If anyone was here 2 weeks ago for the live stream that I did, there was a lot of new stuff happening in the month of March. We got results from 4 major cosmology experiments. So we've got a new CMB map and confirmation that all CMB measurements seem to agree. So let me just tell you what the CMB is, because I just mentioned CMB map. And of course, what to stream without an image that is refusing to load. Well, this is fun. My slides are not loading. There we go. There we are. Had to bring that up. Okay. CMB, cosmic microwave background radiation. This is the oldest light we can see in the universe. This is a snapshot of what the universe looked like 380,000 years after the end of inflation. What you can see here are hot spots and cold splodges. I try to mix the words splodges and spots. Hot spots and cold spots, hot splodges, cold splodges. And what this is showing us is the overall temperature difference in the very early universe. So in the early universe, there were 4 main components. Dark matter was doing its own thing. Then we had protons, we had electrons, and we had photons, which are particles of light. As the universe gradually cooled down, the protons and the electrons could combine together to form the first atoms. And at this point, the photons and particles of light could break away and start traveling freely throughout the universe. They have been traveling freely ever since. And today they make up the cosmic microwave background radiation. We call it cosmic because it's in the cosmos, background because it's behind everything, radiation because it's photons, and microwave because it is in the microwave range of the electromagnetic spectrum, because the wavelength of these photons, of these particles, has gradually shifted. CMB, my favorite thing in the universe, as many of you know. So, as I was saying, if you were here 2 weeks ago, this is just in answer to David's question of how's the universe doing. So, yes, we got a new CMB map, a new map like this picture. This one that I love to flash here. This is taken by the Planck telescope, which was a joint ESA and NASA collaboration, launched in 2009. Took data between 2013 and took data up until 2013. The last data release was this one that you see here. However, a couple of weeks ago, we got new results from the Atacama Cosmology Telescope, which is a ground-based CMB mission, and it gave us a new map, which is a small region of this one, but staring very intently at that small region. And the Atacama Cosmology Telescope agrees with the Planck findings and kind of solidifies our standard model of cosmology. Our standard model of cosmology is a fancy way of saying the model that best describes the universe. We know that the universe has 4.9% normal matter. This is everything you see, everything you're accustomed to, everything from me to my very cute cat to my tea mug to the stars you see in the night sky. All of this is normal matter. This only accounts for 4.9% of the energy budget of the observable universe. There is another 26.2% in the form of dark matter. Dark matter is this weird type of matter that interacts via the gravitational force, but does not interact via the electromagnetic force. This means that dark matter is essentially invisible. It does not emit light, it does not reflect light, does not absorb light. However, we know that it's there due to the way it gravitationally affects other objects in the universe. Then we have an amazing 69%, which is in the form of dark energy. That is a huge amount. Dark energy is this weird type of energy that is driving the accelerated expansion of the universe, and that's pretty much everything we think we know about dark energy. Caveat, put a star here. I will come back to this in a few seconds, in a minute or so. This idea that the universe has dark energy and cold dark matter is our standard model of cosmology. These numbers, these exact 4.9, 26.2, 68.9, these numbers do in fact come from our CMB map, from the cosmic microwave background radiation. So, yes, so just laughing at some of the comments. So the Atacama Cosmology Telescope found that by measuring the CMB with a completely different detector to the one that produced the first map that I keep showing you, not the first, but this map here. We have many different CMB maps. This is just the most precise one. But the Atacama Cosmology Telescope measured this and found very good agreement with the results and the numbers we get from Planck. So that was a new thing that happened in cosmology last month. I know the question was, how is the universe? But I interpreted like, how is our understanding of the universe? And I'm not even sure if it was a question. Anyway, I will catch up with the other comments in a sec. Just wanted to summarize what we discussed 2 weeks ago, because it was an almost 2-hour long stream. New CMB map in agreement with our existing CMB map. Point number 2. We had a weak lensing experiment. These are experiments that measure how much galaxies are distorted due to massive objects such as dark matter, because even though light doesn't experience dark matter in any way or doesn't interact with dark matter in any way, dark matter can curve space-time. It creates a gravitational presence which distorts the space-time around it and causes anything traveling through space-time to be deflected. So that means that light can be deflected around a massive object such as dark matter. We can use this deflection of light to study how gravity behaves and how matter behaves. And one type of experiment that does this is what is known as cosmic shear experiments, where we look at how distorted galaxies are due to massive things like dark matter. There has been a problem in the last 5 years or so known as the sigma 8 tension or the S8 tension, which basically says that when we measure how matter clumps together on scales of about make a box, put 8 galaxies in there on those scales, on that size of the universe, that we look at how matter clusters together or how matter clumps. We can get these numbers of how much does matter clump out of the cosmic microwave background radiation projecting forward, or we can get this from weak lensing or cosmic shear experiments. For the last 5 years, there has been a discrepancy between these, a disagreement. However, the latest cosmic shear measurements that were released in March found very close agreement to the cosmic microwave background radiation ones. So it seems like our standard model of cosmology and our CMB maps are pretty robust. There was also the first release of Euclid images in March, which are very, very cool. The first real deep field Euclid images, which are very cool. And then we also got the latest results on DISI, the Dark Energy Spectroscopic Instrument. Again, I will catch up with all the comments. I've seen some very relevant comments. I do want to catch up with them soon. Just quickly recapping everything I discussed last week, and also just leaving it open for you all to ask more questions. So, Dark Energy Spectroscopic Instrument is a ground-based telescope that is trying to measure how dark energy behaves. So it measures galaxies out to about 10 billion light years away. So we're getting light that was emitted from these galaxies 10 billion years ago or more. And we can use we look at how galaxies look further and further out into the universe, which means looking at galaxies further and further back in time based on how long it took the light to reach us. And by doing that, we can figure out how structures are changing over time. And this allows us to kind of measure dark energy. And when I showed this map just now, I said, dark energy accounts for 68.9% of the energy budget of the observable universe. And that's it, everything we know about dark energy, it's pushing everything outwards. However, up until now, our standard model of cosmology kind of assumes that dark energy is constant. This means that the rate at which it pushes matter away from everything else is pretty much constant throughout cosmic evolution. However, what the DISI results showed us a couple of weeks ago, first a year ago, and then again a couple of weeks ago with more data, is that maybe dark energy is changing throughout cosmic evolution. So maybe it's not a cosmological constant. This means that we change our phrasing from we don't know what dark energy is, but we think it's constant, to we don't know what dark energy is, but we don't think it's constant anymore. So in answer to the question of how's the universe is good. The universe is still there, which is always good. And our standard model of cosmology seems to be robust in some areas. We now have good agreement between different CMB missions. We have good agreement between CMB and weak lensing missions. However, the Dark Energy Spectroscopic Instrument has perhaps given us a new perspective on what dark energy actually is. So that's pretty cool. Okay, so let me just see the replies to this, and then I will go back to the other questions here, because there's also some other comments I want to address. Let's see, where were we? Just because I want to reply to these comments here about dark matter. Where were we? Am I going to replace this photo of the CMB with a new one? I am not. So I saw a couple people mention this here in the comments. So this photo of the cosmic microwave background radiation is a full sky photo. It is the full sky of the CMB. This is basically a deconstructed sphere around us. The new one is a very precise image of a small snippet of this, like a small square of this map. And while the new one is really, really precise, I personally prefer the full sky map. So I am not going to replace the full sky one with the new one, even though the new one is very pretty. I personally prefer this one. But any CMB map is a good CMB map. I'm just kind of partial to this one. This one is my favorite. There's a comment here. If I was a cosmologist, 68.9 dark energy would be bugging me so much. Yeah. I started the stream by saying, I'm a cosmologist, I study the universe. And then I tell you, actually, we only understand about 5% of the universe, and there's this 68.9% that is dark energy that we don't know much about. And there's this 26.2% that is dark matter, which we also don't know much about. Kind of failing at our jobs as cosmologists, like our mission, study the universe. How are we doing? Well, we know what we don't understand. And that is 95% of the universe. So that is cool. That is very, very cool. Keeping on the topic of dark matter, and then I'm going to go straight from the top and read all of the comments, because I saw there were also some questions like how was the concert, how were the cats, and I want to answer those as well. And thank you, David Dunn, for saying hello from both YouTube and Twitch. It's always nice. I always get consistently at least one viewer on Twitch, and I'm pretty sure it's you, David, so thank you for that. Okay, comment from just Akina here. So dark matter is definitely matter if it curves space-time. That's interesting. Yes, it is definitely matter, but we cannot observe it properly because it does not interact with light. So it is essentially invisible. We call it dark matter because it's dark, it's mysterious. Calling it invisible, calling it invisible matter would actually be a much better name for it, because it is invisible as far as we are aware. It does not interact with other things in the standard model of particle physics. It doesn't interact with normal matter. I say normal matter because we call it a normal matter because it's what we're used to, but it is the smallest one. It's only 5%, whereas dark matter is 5 times more abundant. But we are just more used to thinking of normal matter. So yes, dark matter is very weird. We know for sure, we're pretty sure it's there. At least it's the best idea we have to explain a lot of different things, ranging from the cosmic microwave background radiation to the distribution of galaxies in the universe, to how galaxies behave when they crash together, to things like weak lensing. All of these, to the motion of stars in galaxies. All of this points a picture. Hey, big stretch, baby. That was a big stretch. Sorry, Cat did a big stretch. I have to point that out to him, because obviously, if you have a cat and you don't say big stretch when they do a big stretch, what are you doing? He just did a very big stretch. I was saying, yes, we have a lot of pieces of evidence that point to the fact that there should be something called dark matter in the universe, or some type of matter that does not interact via light but does interact gravitationally. This is what the evidence is kind of pointing towards. So even though we don't know what dark matter is, we've narrowed it down. We've ruled out a lot of ideas. We know what dark matter isn't. We're pretty sure it's not space dragons, but we don't know what it is. And this is largely because it is invisible and very, very non-interacting, so very difficult to actually detect or measure in any conceivable way. And as Scott says, the fact that we don't know 95% of the universe is job security. They need to keep cosmologists around because we haven't yet figured out 95% of the universe. So, that's the job. And sticking with dark energy here, because there's a comment from James. Hi, James. Nice to see you as well. If dark energy is not a constant, doesn't that mean the expansion rate of the universe should be rethought as well? And follow up, very similar question here from David Dunn. The dark energy variability might solve the Hubble tension. So there is another persistent discrepancy in our standard model of cosmology when we make measurements or ask the question of how fast is the universe expanding today. There are several different ways we can go about answering this question, and we don't always get the same answer depending on how we ask the question, which is a problem. Our answers range from 67 in some arbitrary units that you don't need to care about to 73 in the same arbitrary unit. It's the same random unit, weird unit. So this is not really arbitrary units, it's just like a very weird unit. So this is known as the Hubble tension, or the crisis in the expansion rate of the universe. So there is the very valid question to ask, which two of you just mentioned here in different forms. Same question is, can this new idea that dark energy is not constant help us explain the Hubble tension? And it doesn't seem like it does, because it does say that the rate of expansion, the kind of, it's not so much focused on the rate of expansion, but on how strong dark energy is, so the strength of dark energy. And it doesn't seem to go in the right direction towards solving the Hubble tension. So even though they are heavily related, if we're talking about dark energy and we're talking about expansion of the universe and expansion rate of the universe, these are very linked concepts, but it doesn't seem like the dizzy results can actually solve the Hubble tension. So yeah, what's 6 arbitrary units between friends? Exactly. So the unit, if anyone is curious, as David Dunn just said, is kilometer per second per megaparsec. So this basically means if you take a chunk of 1 megaparsec of the sky, that is expanding at a specific rate of kilometer per second. But this basically means you're talking about something that has an expansion rate of 1/time. As weird units, as advertised. So, yeah, what is 6 arbitrary units between friends? The difference between 67 and 73 wouldn't be dramatic if it was like 67 plus minus 10, 73 plus minus 10. The problem is these experiments are very, very precise. So one is telling us it's somewhere between 66 and 68, and the other one is telling us it's somewhere between 72 and 74. And the fact that both measurements are extremely precise makes it very hard to reconcile them, to bring them together. I like the suggestion here from Paul that dark matter is a huge fleet of cloaked Romulan ships. I mean, I can't disprove that. Following up with dark matter, there is a comment here from Takina. Sorry, just to recap what I was saying there. We do not think that the dizzy results that this dark energy might be thawing, might be changing its behavior throughout cosmic evolution. That doesn't seem like it's giving us a solution to why the expansion rate of the universe is different when we use different probes, different local measurements, or different ways of measuring this. That is still an open question that we need to solve. Takina asked a follow-up question here. Doesn't interact with light. Indeed, dark matter does not interact with light. Have we sent a probe to dark matter? That's something I really want to be a space mission like yesterday. Yes. Unfortunately, how do you measure something that doesn't interact? It's not just it doesn't interact with light, it doesn't interact with anything. Like, there could be dark matter passing through me right now and I would not know. There could be dark matter passing through the Earth and we would not know. So it's very, very hard to make a detector to find something that just does not interact. You know, it's like if you're trying to contact someone who doesn't have a phone, doesn't check emails, doesn't use any type of technology, and you don't know their address. It's going to be quite hard to figure out, how do I contact this person? Unfortunately, we don't have a phone book for dark matter. My analogy got weird there. Yeah, so it would be very cool to try to measure dark matter, but because dark matter fundamentally doesn't interact, it's very hard to measure it. We have a lot of other ways where we try to figure out what dark matter is. We can see if we can ask the question like, okay, if dark matter, we know that if you have a proton and an antiproton, which is like a proton's evil twin, it's the same, but reverse quantum numbers, it's the antiparticle. But if you have a proton and an antiproton and these come together, they will annihilate and produce radiation, or photons, or particles of light. So we can ask the question of what happens if dark matter and anti-dark matter smash together. Would they produce light? Would they produce radiation? Would they produce something we can see? So then we try to measure up things in the universe and see if we have too many or too few of something. And then we ask the question of, did potentially dark matter produce this? You can also try to produce dark matter in a lab by doing the inverse process where you smash things together and you know that the energy you put in should be equal to the energy that comes out. So you smash particles together, you measure the energy of everything that comes out. If you're missing energy, it might have been carried away by dark matter. So that is kind of one idea we have towards dark matter, but it is fundamentally very difficult to measure something that does not interact with our detectors, with our eyes, with our light, with anything that we can conceivably use to measure it. Okay, there are follow-up comments here about neutrinos. I will get to those. So let me just take it from the top because there were some questions I wanted to answer. And all of this 20-minute answer was just to David asking, how is the universe these days? The universe is good. And before I forget, I saw a very, very, very cool documentary about moths the other day. Yes, Friday. What are days? We had an event at my campus called Faculty Day, where it's all of the Faculty of Science celebrating achievements over the last year. So it's really cool. You get all of the faculty together. It meant I got to chat to people in other departments that I don't speak to often, chat to my friends in the chemistry building, people from just all of the departments coming together. It's very, very cool. And apparently, people at my university have developed a camera that can take really, really cool, almost like slices of images of microscopic things and then put them together to create a 3D version. And they use this to study moths. So we were getting really, really high detailed images of moths, and it was like a 30-minute documentary, and they just showed it in the lecture room with dim lights right before lunch. I was just there like, I'm just going to chill and watch very cool documentary about moths. Anyway, David Howden, I wanted to tell you that I saw a very cool documentary about moths. You would have appreciated it. It was very cool. Moths are cool. Okay, back to the top. Let's go through the comments. Okay, that was a long answer. Let's just take a breath before we jump into the rest of the comments that were there. Oh, that tea is still a bit too hot. As you all know, my tea needs to be cold before I drink it. It will be good in about 10 minutes. And once it's been sat there for 35 minutes, then it's good. Okay, there was a comment from Prath of how was the concert. This is coming from the fact that last week I was not online because I was at a conference. Not at a conference, sorry, I was at a concert. See, Brain, where is Brain today? I was at a concert. And it was an amazing concert last Sunday. It was a mix of rock music performed by classical musicians. So it was like rock and orchestra and classic music combined. It was really, really cool. It was an amazing concert. I'm really glad I went. I had a great time. Yeah. And, going to a rock concert is always an excuse to wear ridiculously cool outfits. So it was nice. I really enjoyed the concert. Thank you for asking, Beth. It was a very nice concert. I'm glad I went. And I got home. The concert started at the same time I usually do my stream. I got home close to midnight. Yeah, I did not get much sleep. If you all are wondering why I seem a bit scattered today, because I do seem a bit scattered, I have not had a good night's sleep in about 2 weeks. I have messed up my sleep schedule. My insomnia is back. This happens every spring, so I'm not concerned about it. Please do not give me advice on how to sleep. I assure you, I have tried everything. I'm not requesting advice. But the continuous lack of sleep has merged with my long COVID brain fog. And my brain is kind of all over the place right now. The last week, I've realized my brain is not doing what it should be doing. But that's okay. This happens every spring. Nothing to be concerned about. It will reset. I will reset my sleep schedule within a week or two. But if you're all wondering why I'm mixing the words concert and conference and why my brain is jumping from one topic to another even more than it usually does, that is why. Just did the thing of heard a random noise and it's like, what is that cat up to? One of the cats is up to mischief. My tea is still too hot. Okay, so where were we? Let's see. I wanted to answer all of the questions, or at least just kind of acknowledge the questions here, because some people just pop in and say hi, and that's okay. Yes, then comment from Paul. 25 minutes ago by now. I went to the rec center this morning and the desk attendant was talking to another visitor about his home telescope and love of cosmology. That's so cool. I love when you encounter things like that in the wild and it's just like, wow, other people like these things too. Oh no, zoomies time. I have one cat here about to start zooming and one over there kind of provoking the zoomies. So this is gonna get chaotic. Please don't jump on my keyboard when you run away. Yes, if you hear me making random comments, you can assume I'm talking to a cat. Okay, he's up to mischief. That's fine. They have decided, my cats have decided that when I'm talking, it's time for them to be active as well. So when I'm doing the live stream, they both get full on zoomies mode. Also when I'm in work meetings. Anyway. What did he just knock over? That's a problem for after the stream, but I'm not sure if you all can hear the background noises, but something just fell in the bedroom. Anyway, problem for later. But yes, it's always very cool when you find random people talking about cosmology and stuff like that. I'm like, hey, can I join your conversation about physics and cosmology? It's very cool. Related to what I'm just getting distracted by here, there was a question from Scott of, do your cats get along or do they fight? They get along really well. They are a bonded pair. So they have been together, they're brothers, they've been together most of their lives. And they get on really well. They do like play fighting, which is what they're about to start doing now, but they do get on really well. They don't fight, so that's good. Occasionally I'm like, are you guys still play fighting? Because, that seems a bit serious, but yeah, they're just play fighting. Okay, there was a question from Takina. Have you ever talked about Mars colonization? Many times, yes. I'm just making a note of that. I'm going to quickly go through the comments and then I will get back to Mars colonization. And I need to write that properly because initially I just wrote Mars colon and then I made myself laugh. So now I've now I've written it properly. Okay. Comment from Prath. I'm going to have to press you about follow-up for solar quarks from virtual particle generation. You know, I have this trusty notebook where I write down open questions. And then periodically I take this notebook out and I look at open questions and think, oh, I should answer those. And then sometimes I do. The problem is this specific notebook stops existing when the stream stops. It goes into the cupboard and it doesn't come out again until the following Sunday. So what happened is 10 minutes before I went live today, I picked up this trusty notebook. I flicked through the pages and I saw the comment of look into how quarks look into the idea of quark confinement and virtual particles. And I was like, oh yeah, Parth is going to ask me about that. I have not looked into it. So very predictably, Parth, you asked me about that. I have not looked into it. It's in my notebook. Doesn't mean it's in my brain. But my notebook knows that I need to answer this question. I will try to answer it at some point. Some point, maybe. Okay, I'm going to do a quick fire round of questions just to catch up with the comments. Then I'm going to talk about Mars colonization. There was a question from Paul here. If I shine a laser, I assume the curved path is the shape of space due to gravity. But if a spaceman is in orbit unpowered, that's a very steeper curve. Is that also the shape of space? Let me read that again. You shine the laser, the curved path is the shape of space due to gravity. Yes. But if a spaceman is in orbit unpowered, that's a very steeper curve. Is that also the shape of space? I'm not completely sure I understand that question, Paul. But yes, in general, you can assume that if someone's in orbit, they're further away from the gravitational pull than us on Earth. So the difference in the gravitational field is going to be substantially more noticeable. We know that the gravitational force is an inverse square law. So if you double the distance to an object, the gravitational force changes dramatically. It changes by the distance squared. So an astronaut in orbit is going to experience a very vastly different gravitational field to someone here on Earth. I'm not completely sure if that's what you're asking for, but that's kind of what I got out of that. Feel free to ask again if that's not what you actually meant to ask. Comment from David here. I'm as you can see, I'm just at the old comments. I'll jump to the new ones very, very soon. Tempted to ask again about why some forces act only at a finite distance, but others are infinite. That's a very hard question to answer without math. That is also in my notebook of forces and distances. I wonder if I can get someone in my office who wants to answer that question without math. I will see if I can recruit someone at work who wants to join the live stream to answer why the forces have different strengths across different distances and how we can answer that without math, because that is a very cool question. Okay, let's see. More questions. I covered those questions. Question from Ben here. Okay, I will get back to that in a minute. Let me just jump to the end and then we can go back to that. So I have an open question here about Planck length that I want to get to. I'm writing this down because I don't trust my scattered brain to remember this today. And there's a question about Mars that I want to answer. And there is a question about PTA that I should answer, pulsar timing away from John. Okay, what else? Let me jump to the bottom and then go back up. We answered a bunch of these questions. There's the talk of neutrinos. Going back to the idea of dark matter, Takina followed up with it. It curves space-time, so it means its energy is mc squared. So for dark matter to be matter, wouldn't the equation be the same technically? Yes. But even if the energy is the same, there's more to the equation than that. E equals mc squared is not actually the full picture. It should be E equals mc squared plus, mp4 or pc4, something like that. There's an additional term. But yes, even though it is the same, the fundamental problem with dark matter is it does not interact with anything. And that makes it very, very difficult to measure. So even though we know that it should obey the laws of conservation of energy and things like that, it is still extremely difficult to measure. So question from Milamin Haddad here, not really a question about the universe. I've been enjoying your content a lot lately, thank you. And I was wondering if you know scientists who make lives like yours where they answer and talk about physics. Not so much anymore, to be honest. There used to be about six of us doing this on Haps back in the day and on Periscope back in the day. There was a group of us, but most of them have either stopped doing it. Of course, you have David Dunn doing the astronomy talk still on YouTube. So if you want more science, follow David Dunn on YouTube for the astronomy show, and that's also a more like physics interactive streams. But I don't think so. I know many people who do the interactive thing anymore. There used to be a bunch of us, but it has kind of there's a few people that I haven't really seen lately. So I'm not sure if there's many of us doing this anymore. And I think for me that's kind of an advantage because this is the niche I've carved out on YouTube is my show is live. There's no special effects, there's no editing, there's no polished content. It's just I get here, I talk live, and then I go. And the content does not require me to then go back and touch it ever again, which is easier for me. Comment from Perth that I should just leave this notebook unattended in my faculty cafeteria. Yeah, see, the problem is this notebook. This notebook is one that has a lot of random things, and like my pictures, you just glance through this notebook and it's like, what? Why was I drawing a solar system? I have no idea. What does it say up there? It says probes. So there's just a picture of a solar system and the word probe. Okay, yeah, David Dunn's show is on Twitch, not on YouTube, but yes. Do follow David Dunn as well for more science talks. But yeah, I should take this notebook someday and ask my colleagues, like, okay, let's go through my list of questions. But also, I would not be comfortable leaving this notebook unattended because of the random way in which I sketch things or I leave comments to myself. Like there is still just a big question on one page that just says hydrogen with a question mark, and I have no idea what the question was or what the answer to that question was supposed to be. But yes, there's also another page that's just a question here of energy conservation. I'm like, yes, energy conservation is a thing. Why does it have a question mark? Anyway, yes, I do not leave this notebook unattended. But on the topic of scientists doing this kind of live stream and interactive show, while I don't know so many currently, I believe there's a social media platform launching very, very soon that has that as its sole focus. It's like the exchange of knowledge. I signed up for the like early launch thing about a year ago and honestly completely forgot about it until I got an email a few days ago like launch is coming. So I'm not sure how much I'm allowed to talk about that yet, but stay tuned because over the next couple of weeks I might mention, or I'm going to try out and then mention to you if it's worth it, an app that might be targeted specifically towards contacting people who are experts on the topic and learning from them. So I'll see. I'll let you know. Once I have more information. For now, I just got an email of like, hey, hope you didn't forget us. It's like I did actually, but thanks for the reminder. Anyway, you'll hear more about that soon. It's also something that I might be involved in, depending how it goes. We'll see. Okay, there are 3 questions I want to answer. And I'm just going to quickly glance at the one that Ben asked and answer that one first. And then there's pulsar timing rate, and then there's Mars colonization. I'm doing it in that order just because that's the order I prefer to do these questions in. Comment from Ben here. Do you think we will ever measure Planck time or length? What happens if those limits are found to be exceeded? So the Planck length and the Planck time are the smallest unit of time or the smallest unit of length that we can conceive of. It's kind of inbuilt into the way we construct our physics that once you go down small enough, the smallest possible thing is the Planck length. Now, of course, we've been there before, right? When we coined the atom, when we were like, the atom is indivisible. And then, of course, we found that the atom is actually made of protons and neutrons. And then we're like, protons and neutrons are indivisible. Undivisible, cannot be split, cannot be parted. And then we figured out that actually protons and neutrons are made up of quarks. Now, the idea is that the Planck length is the smallest length possible. The Planck time is the smallest time possible. And this is just determined by kind of some quantum properties that, based on what we've been able to observe and our kind of fundamental understanding of the universe, the Planck time is, by definition, the smallest time we can have. It's unlikely that we will ever be able to be sensitive to measure the Planck time or the Planck length. And if we could, there's not any way we could go smaller than that, because we've built this around the notion that these are the smallest limits. And even though we have, pushed these limits before with the Planck length and the Planck time, it's kind of inbuilt in the way that we define things that these are going to be the smallest things possible. I just want to check the exact definition of this, which would help if I turn my keyboard on. Yes, the definitions people always give for these are always feel like a roundabout way. Like the Planck units are defined in terms of universal constants. So this means that it's not something that is relative to my measuring device, to me saying like, okay, this is 20 centimeters, I can measure it. The Planck units, Planck length, Planck time, are defined in terms of the speed of light, the the gravitational constants, the Planck constant, which is one that is related to quantum physics, and the Boltzmann constant, which relates the average thermal energy of particles with, the temperature. So these are four universal constants. They are numbers that we have measured in nature, and we use these four numbers to kind of define our Planck length or our Planck units, which means we can't really push it smaller, because these are the quantities that we have defined to be the smallest based on these natural constants, if that makes sense. So short version there is we don't think that we don't think that this is going to be pushed smaller, if that makes sense. Yes. So the question was, can we go beyond Planck length or Planck time? And my answer would be no. Okay, I see a lot of people here recommending different YouTubers or different people to catch for science. That is very cool. I'm not familiar with all of them, but the people being recommended here, worth checking out. Dr. Becky is mentioned here by Brad. Dr. Becky is great. I don't think any of her content is interactive, but she has a lot of really, really cool content about the universe. Helora Stevans was a guest on one of my streams at some point. Talks about astrophysics again. I don't think her content is interactive, but it is very cool content as well. There was, of course, Physics Girl doing a lot of very cool content before, not so much anymore. But yes, there are a lot of people doing a lot of cool science outreach out there. You can find a lot of science outreach on YouTube, on other platforms, on TikTok, but I think the interactive one is a bit of a niche. Okay, what about Planck temperature, aka absolute hot? Yeah, so there's not a Planck temperature. We define a Planck energy, and then you can get the temperature from the energy using the Boltzmann constant. Indivisible. Okay, thank you, David. Is that how you pronounce it? Indivisible? Indivisible. Yeah, that sounds right. Indivisible. I prefer individable. Undividable will not be divided. Indivisible makes sense. I will not remember that word. That's one of those words, I am technically a native speaker, but there are some words that my brain just refuses to store. And the correct pronunciation of indivisible is one of them. Another one that I always mispronounce is haphazardously or haphazard, because my brain merges the P and the H, and I'm like, haphazard. That word I hate. You will never hear me say that intentionally. Like now I made a point of saying that word, but that is one of those words that I've seen in writing and I don't like pronouncing out loud. The same as many of you know with xenon versus xenon, the gas, the noble gas. It is xenon. I have learned that now. I used to call it xenon. Appreciate the joke here, Paul. Scott, I'm actually just going to put it on the screen because that's a funny joke, and I always appreciate the funny jokes. Yeah, Helora was on my stream back in. Was it still on Periscope or was it that already on HAPS? I believe that was on HAPS. That was back in the HAPS days. The reason Helora was on the stream was to talk about the life cycle of stars, and that is the stream where we addressed the question of blue dwarfs, which was a question that Scott had been asking me for 5 or 6 years. So we finally addressed that on the stream where Helora was on there. Yeah, so I don't believe that one is on YouTube, actually. So it was in the HAPS days, which means the problem is Cup of Cosmology has changed platforms several times. I used to be on Periscope, then I moved to HAPS. And then I moved to YouTube via Restream. So all of my old streams before the YouTube days are not necessarily publicly available. It's also why, Cup of Cosmology has been going for almost 10 years now, but there's only 3 years of streams on YouTube because all of the previous ones did not make it over. However, I do have a copy of every stream I've ever done, except like a few that I've intentionally deleted. I do have copies of all of these streams. And there is the plan to one day gradually upload them, not the earlier ones, because honestly, I no longer stand by my earlier streams. When Cup of Cosmology was getting started, there were a lot of things that needed to be improved, and been a learning curve. But I'm pretty sure that the ones from HAPS, I can easily migrate to YouTube because I have them downloaded. It's just a question of editing them a bit, doing a bit of processing, and putting them up there. So I can ping Helloa and check if she's happy to have her stream on YouTube, and if so, I will repost it, because especially the ones where I had guests, I think it would be good to repost those. Comment here from Lethargo. To measure something of Planck length or smaller, you would have to interact with it by putting so much energy in such a small space that it will make a little black hole. That sounds believable. Yes, that sounds accurate. Yes, I agree with that comment. That is a good way of phrasing it. Yes, indeed. Right. Yes, indivisible is part of your Pledge of Allegiance. That is so dystopian, by the way, that schools start with Pledge of Allegiance. I hope you all Americans realize how dystopian that is. I guess, you just look at your government and you're in a dystopia, but the Pledge of Allegiance, like every morning, swear allegiance to the flag. What are you doing? Why is this a thing? Anyway, no shade on my American friends, just seriously, what's up with that? AI said there are more water molecules in a drop of water than grains of sand on Earth. What? Oh, okay, yes. Yes. As soon as a sentence starts with AI said, I'm immediately going to be like, I don't care what AI said. What you're actually saying is AI used auto predictive to come up with a sentence I thought was believable. But yes, there are more water molecules in one drop of water than grains of sand on Earth. I believe that is correct. Yes. There's also more stars in the night sky than grains of sand on the entire planet, I believe. Yeah, it's those numbers. But that also, humans are just terrible at numbers and at comprehending big and small things. It's unfathomably big. It's big. At some point we just stop figuring out distances. I was rereading something about the Titanic the other day, just one of those random Wikipedia rabbit hole things, and I was just hit by the stat like the Titanic is 380 meters underground. It's like almost 4 kilometers down in the water. I'm like, how does the water go down 4 kilometers? And then there's like Mariana Trench is 11 kilometers. That's a whole city away. How do you take that distance between cities and put it underwater? Humans are terrible at distances and at sizes and at thinking about unfathomably big things and unfathomably small things. And I just realized that unfathomable is also a word I do not like saying out loud. Yes, the intentionally deleted streams are the scandalous ones. It's where I reveal things. No, the reason I delete them is because by its very nature, Cup of Cosmology is live. I'm going to make mistakes. It's going to happen. Sometimes I will answer questions and the answer I give you will not be 100% correct. I always try to err on the side of caution, and if I'm not sure about something, I try to always tell you. But I don't know everything, and there will be mistakes. Often what happens if I make a mistake in a stream, I correct it the following week, or I point it out the following week. In some of my earlier streams, I feel like I often try to answer questions, even if I was only 50% sure about the answer. And some of the answers were not as correct as I would like them to be. And even though I did then point it out afterwards, that kind of assumes that you're watching multiple streams to figure this out. So there's been a couple streams where I've watched them back and I've been like, I just don't really want to put that out there again, now that I have the choice of choosing which ones get uploaded to YouTube and which don't, and which stay on my hard drive. Some of them have just been removed because there's no need. Annoyingly, there is one stream that I lost, which I would really like to find, which is the stream where we got the first announcement of gravitational waves, the first detection of gravitational waves, and I was so hyper. I was bouncing up and down. The problem is, I did that stream. Usually, I had a setup for my streams. I had a tablet. This was back in the Periscope days, and everything was stored automatically. And that one, because it was a spur of the moment thing, I did it on my phone, and it did not save it. And that is one stream that I would like to go back and watch. And that is a stream that is lost. I don't have any copy of the stream where the gravitational wave announcement was. And I'm kind of sad about that because I really liked it. And unfortunately, it was not possible to download all of the streams from Periscope. So I don't have that one. Yeah, avocado's number, not avocado. Avocado's number is like 10 to the 23. What does that mean? It's one followed by 23 zeros. Sure, what does that mean? And the fact that humans are so bad at figuring out numbers is also something that becomes very apparent when talking about money. If I say I have €1 billion, I do not. But if I did, that is not a number that most of us can comprehend. The difference between a millionaire and a billionaire is insane. You could work every day for the rest of your life. You could work 12 hours a day, every day for the rest of your life at making $100 an hour. You will not become a billionaire. And this is something that is very easy for people to then kind of forget. The difference between a millionaire and a billionaire is staggering, but we all just kind of lose track of these numbers, and we're like, billion, million, it's just a big number. It's the same. It's not the same. It's really not the same. People make six figure. If you ever make a six-figure salary, that is still not close to a billion. A billion is a 12-figure salary. That is this huge jump. Anyway, I did not mean to casually slide into tax the rich and anti-billionaire propaganda there, but you all know it was coming. Why would I pass up that excuse? Okay, I will not delete the Planet Olympics. So Planet Olympics is actually one of my favorite streams. It is on YouTube. That's one I did on Haps. It did migrate to YouTube. I do believe that the Planet Olympics is coming up to 4 years, which means it's time for the next Planet Olympics. The Planet Olympics, for anyone who doesn't know, is was a stream that I did a couple years ago where we used the fact that the show is interactive, and I basically told people a lot of space facts, and you got to vote on which was the coolest planet, and we held a whole like Olympic Games of the planets. There absolutely needs to be a second edition of this. So maybe this summer I should check when we did Planet Olympics Part 1, but Planet Olympics Part 2 should happen. Yes, that is one of my favorite streams. That is on YouTube. You can go watch it. That will not be deleted. I like that one. Yeah, humans aren't good at statistics. We're not attuned to how stats work. We're not attuned to how big numbers work. Comment from Paul here: 12-figure salary. That's like twice as big as a six-figure salary. No, but yes, that's how people think. But also no. Yeah, it's a big issue in government communications, as David Howden is saying here. People think 10 million is a lot of money rather than being a rounding error. Exactly. Yeah, and this is the problem. At some point, our brains can't process. It's unfathomable, and then we're just like, oh yeah, it's a big number. No, it's Pluto is the coolest planet. I did let Pluto enter the Planet Olympics. Pluto did not win the Planet Olympics. I believe the winner of the Planet Olympics ended up being Earth, and I was so disappointed in you all for that. Like, why? How did you all let Earth win the Planet Olympics? How did that happen? We were voting on the coolest planet, and people were like, well, Earth has humans. I'm like, Jupiter has spots. Saturn has a hexagonal storm, and you're all voting for Earth. Yeah, controversial, but I was annoyed at you all for the results of the Planet Olympics. Anyway, Planet Olympics Part 2 needs to happen. Oh, Moon Olympics or Dwarf Planet Edition, Exoplanet Edition. Ooh, that could be fun. Yeah, we need to expand it beyond just solar system planets. Anyway, Planet Olympics, I'll add it to my to-do list. It's going to happen. Yeah, I believe Earth won. Yeah, people were just like, oh, Earth is cute. Earth has humans. Earth is my favorite. Really? Because Venus is right there. Jupiter's right there. Saturn's right there, and y'all chose Earth. I think one of the arguments was like, Earth is the only planet with chocolate, which is true, but yeah. Anyway, We went on about 5 tangents on top of tangents there, but that is fine. Yes, there are old streams that will never see the light of day again. There are old streams that will come back. And I should gradually upload all of the old streams. See, something else that I was doing at some point. Yeah, Earth wins Planet Olympics like America wins the Baseball World Series. Exactly. So at some point, I had a very nice spreadsheet where I had a detailed log of every stream I've ever done, what was discussed in the stream, and a comment of whether it was online or not, whether it was on YouTube or not, whether it's on my webpage, whether it's on the highlight thing. And this was an amazingly cool spreadsheet that really helped me keep track of everything I've ever talked about on these live streams. And then one day I just forgot the existence of this, and it is now 3 years out of date. And I'm not going to to bring that back up, because yeah, that is so out of date by now. Okay, so on the note of billionaires and billionaires being unethical, which is not exactly what I said, but you all know that's what I said, because yeah, I was about to go into another anti-capitalist rant there, but let's bring it back to the question of Mars colonization and space and planet colonization in general. So I think there's already the idea here that we put the word colonization in it, and colonization is something that we should be very wary of and very cautious of. So I am all for space exploration. I am all for going out there and exploring the universe and exploring other planets and maybe taking humans to other worlds. I think this is an amazing endeavor, and it is something that we have to do. You know, space is the final frontier. We have to go there. However, I think there needs to be a lot of questions about the ethics of what we're doing and how it can be done in a good way. Because it's very easy to mess up. And unfortunately, if we mess up, it's not just, we haven't just messed up Earth, which we're doing already. We can mess up entire other planets and civilizations and life forms without even knowing it. And there's a simple example we can give. There's a species on Earth known as tardigrades or space bears, which are these little tiny indestructible microbes that can withstand pretty much anything. You can burn them, you can freeze them, you can starve them, you can deprive them of oxygen, and they will survive. So there was an experiment at some point to kind of figure out how they would do in space. So some of these tardigrades were taken to the moon. However, the satellite carrying them crashed into the moon, which means there are now tardigrades loose on the surface of the moon. Is this a problem? Probably not. But it does mean that we took a species to a celestial body where it's not a native species. And we've already been able to see on Earth the damage that this does. There's been a lot of species that have become extinct because people have taken species across borders or to other countries. And if you introduce a non-native species to a place, you dramatically affect the local ecosystem. So then there's the question of what if we go to Mars and we didn't clean our spaceship properly and something hitched a ride, and we bring a virus or we bring a microbe, and then we find that there's microscopic life forms under the polar caps on Mars. What happens? What have we brought with us? Are we equipped to protecting that planet that we are visiting from ourselves? So while I think space exploration is really good, it's a good idea, we should absolutely be pushing that final frontier. We need to be doing it with ethics and with morality and with carefully taken decisions that involve multiple people. Mars colonization should not be at the whims of a billionaire having his latest glory ride. Oh, I'm going to shoot a car to space. Oh, I'm going to go land on Mars. This is not the way that scientific progress should be done. So I believe that if we want to travel to other planets, if we want to travel to other moons, to other places in the universe, it should be after a lot of ethical considerations and assessed by a panel of experts who are not set out to get money out of it. Colonizing Mars to turn it into the next billboard is not something I'm overly interested in. So then there's a question of, is this ethical? How do we want to do it? What's the purpose of going to Mars? Is the purpose of going to Mars to build a colony? Why does it need to be on the surface? Why can't we build a colony in a space station, for an example? What would we gain from building it on the surface of Mars when we already know that Mars is not a livable planet for humans? So if we'd have to build an enclosure for people on Mars, why not just build something like the space station? Put it in orbit around Mars if you want, but then have a colony living in a space station instead. So I think there's a lot of questions that need to be addressed before we head to Mars. And when a billionaire promises we're going to go to Mars in 4 or 5 years, okay, maybe we get lucky and the technology's there, but should we? Should we figure out how to do this? Very occasionally, humans have shown that they are capable of doing international treaties that respect specific things that are paramount to Earth. For an example, there is the Antarctica Treaty, that every country has stuck to so far, and it's been in place for I think 50, 60 years now. That says that no country may have a military base in Antarctica. Antarctica is purely for scientific research, and no country can have a military base in Antarctica. And this is something that every country has stuck to. And that is really, really cool. And I think this type of idea is something we need before we go to Mars, before we go to other planets, because let's say a billionaire playboy gets us to Mars, or whoever gets us to Mars, who's going to plant a flag there? Who's going to lay claim to it? Who's going to be like, this is mine? Who do we want to lay claim to it? Does it belong to whichever country sent the mission? Do we want the United States to be the ones planting a flag on Mars, being like, this is ours? I put a flag here. I've claimed it. You know, which country would you trust to take over Mars? Or do you want to do it in a way where there's an international treaty? And then again, if we're going to Mars, who are we on this other planet to claim ownership of that planet over there? So yes, my thoughts, personal opinion of Mars colonization, or colonization in general, my opinion is no. Space exploration, I think, is a great idea. I think it's definitely good to push humanity to go out, to explore the stars, to reach to other planets, but it needs to be done in a very careful and ethical way. And right now, I don't think we have assessed this in a way that is the right way. I don't yet think we're ready with the international laws, with the thoughts of what happens when we get to Mars. Why are we going? What happens when we get there? So, Mars colonization, I think inevitably at some point we are going to send a human to Mars. This will be very, very cool when it happens. I just hope that it happens in a way that doesn't make us embarrassed as a species. You know, if imagine a scenario, sci-fi scenario. Imagine this idea that there's a lot of species out there in the universe, and someday we meet them and they ask us like, what have you done to get here? What have you done to be an intergalactic species? I would hope that at that point humanity could look back in pride and say, like, we did it right. Unfortunately, based on human history, that's unlikely to be the case. But yes, voice is breaking. Yeah, I think there's a lot that needs to be considered before we're ready to send someone to Mars. And I would hope that if there was ever a Mars mission, it is not operated at the whims of a billionaire, but rather a scientific endeavor. Comment from Guadav here. There is a TV program called For All Mankind, which explores this idea. You know, I have not yet watched For All of Mankind, but I have heard really good things about it. And I think it's, from what I've heard, it's a show that I really should watch. And yeah, I've heard really good things about it. People whose opinion I respect have told me that For All of Mankind is good. So yeah, I know, go watch it. I haven't seen it. I can't recommend something I haven't seen, but it's on my watch list. Thing is, there's a lot of things on my watch list. On top of that is things like rewatch Doctor Who. If you want to see ethics and space and science and hope mashed together in a very campy way, watch Doctor Who. There's a new season out, new episode yesterday. Personally, spoiler free, because I know a lot of you haven't seen it yet. Personally, I liked the new episode of Doctor Who yesterday. I'm immediately a fan of the new companion. Like one episode in, I'm like, yes, this is a companion I like. But it reminds me a lot of Donna Noble, who is the best companion. Now, this is not a matter of debate. Donna Noble, best companion. Okay, let's see what you all think about space colonization. Comment from Paul here. Maybe it's more ethical to build a huge space colonies instead of on planets. Yeah. for an example, in the space stations. The purpose of going to Mars is for bragging rights, coming from Guadav. I kind of agree with that, that the way it's set up right now, it does feel like it's more about bragging rights than actually doing stuff. Let's see other comments. More comments here. In an alternative history TV program, yes, more what I've elaborated on For Mankind. It's an alternative history TV program which explores the idea of what if the USSR won the Cold War and the space race, indeed. Coming from Prath, as long as humanity is divided by country and race, we cannot even strongly consider sending humans to different planets. Yeah, I don't think humanity is yet at the stage where we're ready to take on this journey. Comment from Takina here, reminding me of how scientists talked about nuclear bombs to politicians and so on, indeed. Comment from John here, I picture the colonization Musk talks about pretty much like the space capitalism portrayed in The Expanse. I have not yet seen The Expanse. That is also on my list. And I agree with the comments here. The Expanse is a great show. I have not seen it. Again, it's one of those shows that I've heard a lot about. It's on my watch list. So yeah, I think from what I've heard, The Expanse is good. And yeah, space capitalism is, I fear, what people are going to go to. So I think my main takeaway of colonization of Mars is let's make it about space exploration and not about space capitalism. And that would be my answer to that. Comment from Takina here. It's interesting to say that it's bragging rights going to Mars when I was thinking about why would anyone need to buy a Lamborghini, which buying a Lambo is never needed. Only reason could be for status or brag. Lamborghinis are nice cars though. Like I agree with what you're saying. Personally, I would never spend my money on a bigger car or a bigger house just for the sake of it. You know, once you have what you need, what's the point of having a fancy ass car sat in the garage just because it looks pretty? I need a car that functions. Anyway, I also don't actually want a car anyway, but hypothetically speaking, if I were to get a car, it would not be a fancy one. It would be a functional car, ideally. Anyway, we're not going to get into that. I'm not going to buy a car anyway. It's a moot point. But yes, buy bigger cars. It's for bragging rights. It serves no purpose. Okay, appreciate all the comments and thoughts. You know, I think the topic of Mars colonization, space colonization is a very open question and it's a very interesting debate. So feel free to put your comments, you know, leave me a comment here if you disagree and you think we should go to Mars tomorrow, Elon Musk will lead the way, you know, feel free to leave these comments. It's always fun when this happens in the comment section. Feel free to give me your opinion and your thoughts on space capitalism and space colonization and how we should do this in a good way. I'm not saying we're going to solve this overnight, but you know, it's good to have these conversations. It's good to have these discussions and to see where we're all coming from. Okay, I once again should be clearer about the comments I write down. I'm just writing down 2 more comments that are already here, but that I want to check again because they're the questions that were asked today. That you know, now they're in the notebook twice. Now I might actually look at them. Okay, The Expanse is great, but depressingly realistic. Sometimes that is something I have also heard. Yes. Also true for Doctor Who sometimes, where they're just like, what if everything is terrible? But don't worry, the Doctor saved the day. What if we colonize Mars and it's a utopian planet? If we do it right, it could be. If we do it right. Then there's the question of what constitutes utopia. How would you define a utopian planet? And you know, we can think of sci-fi. Utopia is the opposite of dystopia. Great. What would make a planet utopia? Because in my utopian planet, there would be no capitalism. Just putting that out there. So how do you define a utopian planet? And is our space exploration program kind of got the aim of a utopian planet? Yeah. How have utopias worked out on Earth? Exactly. Are we capable of building a utopia? Who do we trust to build a utopia? And how would we go about building it? Cool questions. Excellent questions. I do love all of these questions. Not all of them are ones we can answer, but there are some very cool questions there. Okay, let me just scroll up through the comments. When I was on my tangent about streams, why don't I ask the question of how many streams exist? That is an excellent question. So I know there were over 100 on YouTube. On Periscope. There were another at least 100 on Haps. There are over 100 on YouTube, but there is some overlap there. I think There should be around. I think if I'm just counting my own account, there have been around 350 streams approximately. However, there was also the 3 years in Aachen during my PhD and masters when I set up a separate live stream account for my institute, and then there were two streams a week because I had my own streams every Sunday and the institute streams every Wednesday, and there were an additional probably 75 streams on that account. Most of them with me. I think there were only 5 that I was absent from. So I would say I have probably done over 400 of these live streams, which when I say that out loud sounds like an insane amount. That is a lot of live streams. Yeah, I guess if I count all of the ones I've done plus the ones that I did for the Institute in Aachen, we're probably at around 400. And only about 110 of them are on YouTube. So all of the rest are somewhere. I should back them up because they're on a hard drive, and if that hard drive dies, they are gone forever. I should back them up somewhere. Yes. So that is an insane amount of streams thinking about it. That is, especially if we factor in that most streams are like an hour. At least, there's been a lot that have been a lot more than an hour. So that's at least 4,000 hours. Sorry, 400 hours of content. That's a lot. Not bad, not bad. Okay, that is a good thing to count. At some point, I will bring out my spreadsheet. I will update it again just to keep track of things. I wonder, actually, I'm curious now. No, I'm not going to open the spreadsheet now to see when we left off. I am not doing that. I'm not opening the spreadsheet now to see where we left it off. That's a job for me for another day. You have spent about 500 to 600 hours talking to a webcam. Yeah, yeah, that is both very cool, but also kind of somehow not as many hours as it could be. That is very interesting. Huh. Just kind of relating that to my courses, like my university courses, and how many hours you invest in that, and like how many hours you need to get a university degree. My live streams are kind of less than that. So I don't yet have a degree in Cup of Cosmology. Anyway, if you all wondered why everything just tilted, it's because I realized my monitor was slightly askew and I just fixed it slightly. Okay, I'm just going to go back to the top because I'm looking for one very specific question that I only wrote down, look for PTA question, and I cannot remember the question, but I remember that there was an open question about pulsar timing array that I did want to get back to. Okay, let me just glance through questions in general to make sure I have answered most of them. Let's see, we like made notes of these, didn't answer those. We talked about CMB, that was fun. We talked a lot about dark matter, about dark energy. We've talked about Planck length and Planck time. I've reviewed what happened in the previous stream. Okay, yeah, there was a comment from John about an hour ago. Question from John. Are you familiar with studies using pulsar timing array data to map dark matter distribution inside the Milky Way? I am not overly familiar with these. No. How would that work? Let me think about that. So, pulsar timing array. Pulsars are rapidly rotating neutron stars, so stars that are very dense and that are spinning very, very quickly. And by their nature, they have kind of a funnel of light. So this means that a pulsar is basically like a cosmic lighthouse. It is spinning in a specific way, and you get this beam of light going around. This is something that is very, very useful because you can use the arrival time of this beam of light to kind of understand the pulsars. If it's spinning at a specific period, it becomes very predictable. It becomes almost like a cosmic clock. If you expect this beam of light to pass by every 2 hours and 12 minutes, that gives you a measurement that you can do in the universe. You know how the pulsar is behaving. Okay, let me just quickly glance through the rest of the questions, and then I'm going to carry on with this because I just want to make sure that there were no other open topics that I should get back to, just the pulsar timing array one. I think otherwise we kind of covered all of these things. Yeah, we covered these questions, I think. We went on tangents upon tangents, but that's what we always do. Yes, okay. Lots of sci-fi debate there about utopias, about sci-fi. Yes, add to my notebook that I should back up the streams. Yeah. The thing is, I'm just writing back up What does that mean? The thing is, what I should actually do is get another hard drive that I can use to back up what's on one hard drive. I should do that. Yes. Do it, open it. People want me to open the spreadsheet. No, we are not opening the spreadsheet right now. Thank you, Gwada, for the offer of backing up all of the streams. Honestly, what I might actually do is just throw them in my cloud, because I do actually pay for a cloud service, and I have plenty of storage that I could just back up all of my streams in my cloud storage. And now that I say that, I think I might already have done that. I will check that. Anyway, 2-hour streams are not happening. So, fun fact about the YouTube algorithm, I have no idea how it works, but it very much seems like the sweet spot to get the sweet spot that people like is somewhere between 1 hour and 20 and 1 hour and 30 minutes. If it's less than that, it gets fewer views. If it's more than 1 hour and 30, people do not have attention span for it. So I feel like aiming for 1 hour and 20 minutes to 1 hour and 30 minutes is good for these live streams. You know, they used to always be capped at 1 hour. I've already expanded them to be 90 minutes. And I think 90 minutes is kind of the good benchmark. Okay, thank you, John, for following up on the pulsar timing array question, because that makes it a bit easier for me to answer the question. So I was saying, you have pulsars. They are these like cosmic lighthouses. They're rapidly rotating neutron stars, and they produce this specific beam of light. Now, the cool thing is that if you just have one of those, that's great. You can study that pulsar. It's very cool. But if you have a network of pulsars throughout the galaxy, which is what we have, and you measure all of these, you can then kind of infer what is happening in between these pulsars. Like if you have two very precise lighthouses and their arrival time, they always shine their light on you on Earth within a few seconds of each other. And then at some point you see their light and it's within a few minutes of each other. Then you can kind of assume that something has happened in between them that has affected the way light is behaving. So this could be something like the gravitational field has been distorted, which, as we said before, can be caused by dark matter. Dark matter has a big gravitational mass, so it can distort space-time. So one thing that we can use pulsars for is to measure gravitational waves. Gravitational waves are ripples in the fabric of the cosmos that are created by anything moving through the universe in a non-symmetrical way, anything accelerating through the universe. These are tiny, tiny, tiny ripples in the fabric of the cosmos. If a gravitational wave goes through you, you get taller and thinner and then shorter and fatter. Gravitational waves really are distortions of space-time. So if you have a network of pulsars, you can use these pulsars to measure distortions of space and time, which is very, very cool. So you can use pulsars to measure tiny, tiny ripples in the fabric of the cosmos. Now, usually, rather than looking at the lights coming from these pulsars, what we look at is the radio waves coming from these pulsars, because the neutron stars will emit a very specific radio frequency or very specific radio signal. So we use massive radio detectors on Earth. I love radio telescopes because they are just insanely big. Like a radio telescope they usually have these telescopes of diameters of meters, like 80 meters. These telescopes are huge. I love radio telescopes. Honestly, the first time I ever even thought about radio telescopes, tangent time, was in the James Bond film GoldenEye, which I watched as a teenager. I have cat hair in my eye. That's always so annoying. So I watched GoldenEye as a teenager. There's that scene where they have a fight on the satellite dish. Satellite dish, that's the word that I was looking for just now. They have a fight on a satellite dish. You know, there's James Bond there's Sean Bean, and it's very dramatic. And my takeaway of that, you know, James Bond film, cool, but that satellite dish was impressive. And that made me then go look into radio telescopes. Radio telescopes are so cool. Anyway, tangent aside, we use radio telescopes to measure pulsars. So we look at the light coming from these we look at the radio waves coming from these rapidly rotating neutron stars, and we use that to measure how gravity is behaving. So all of that is not answering the question. The question John asked is, can we use pulsar timing array to measure dark matter's gravitational time dilation? Samrav Gupta, great that you could catch the live. Great to see you here. As always, welcome. If you're a first-time viewer, welcome back. If you're a regular, great to have you here. You joined 10 minutes before the end. We're wrapping up soon-ish. Yeah, so the question here of Question here requires me clearing my voice. Right, so the question of can we use pulsar timing array to measure dark matter? I think probably yes, because we know that dark matter affects gravity. It affects the curvature of space-time. However, what I'm trying to figure out, which my brain is not quite clicking on right now, is usually you can use pulsar timing array to measure changes in the gravitational field. And this is why gravitational waves is a prime candidate for this, because it changes the curvature of space and time. Whereas dark matter is kind of just sat there. So what I'm currently thinking is how you use pulsar timing array to measure the distortion in space-time caused by a static object. Now, I'm sure there are people doing this because it sounds like a very cool way. Again, as I mentioned before, we can't really see dark matter, which means studying dark matter is very, very difficult. However, we know that dark matter interacts gravitationally. So using the fact that using gravitational probes to try to study dark matter makes a lot of sense. So using something like pulsar timing array to study dark matter does make a lot of sense. So there are papers looking at this. And kind of the type of thing you might look at is how dark matter changes, if dark matter has any type of coupling or interaction with any other species in the universe. Like, if dark matter very, very, very occasionally bumps into something, this could distort space-time. So this could potentially lead to us measuring some properties of dark matter using pulsar timing array. Let me just very quickly glance at a paper that I've just pulled up. Yeah, okay, so another way of doing it is kind of a two-step process. A two-step process because you can, as I was saying, you can measure gravitational waves, and we don't always know what causes these gravitational waves. There is an idea that you could have some type of dark matter model in the early universe that causes the type of gravitational waves that pulsar timing array measures. So then the idea is, one idea is that you can measure properties of dark matter by measuring the gravitational waves they produce, and we use pulsar timing array for that. Pure. Okay, so to summarize, pulsar timing arrays are experiments that use a network of pulsars which are rapidly rotating neutron stars throughout the galaxy. We use radio telescopes to measure the signal coming from these pulsars, and we can use this to measure any distortion in space-time that happens in a non-continuous way. The prime example of this is gravitational waves, a specific type of gravitational wave that was probably produced in the early universe. And then we can ask the question of what if these gravitational waves were produced by dark matter? And then you do this multi-step process and you end up trying to understand dark matter using pulsar timing array. There are also other ways you can do this, as was just mentioned, for an example, using time dilation of dark matter. But this is something that I cannot explain off the top of my head, and it's not the first paper that I pulled up when I just searched for this. So it is not one that I can answer exactly how they are using time dilation for gravitational waves. Let me just check something here. So as some people in the comments are pointing out here, there was a massive radio telescope called the, where is it? Called the Arecibo telescope, which is unfortunately no longer in operation. And that was indeed the one used in the James Bond film. So a couple years ago, 5 years ago, 2020, the Arecibo Observatory collapsed, and it was a really sad day because it's an amazing radio telescope, and it was really sad to see that one kind of go away. But yes, I do believe that Arecibo was the one that was in the James Bond film. I think so. I think it was, yes. And it is one that is just like a massive, massive, massive dish. How big was the dish? 300 meters. The dish was 300 meters. Yeah. Anyway, sad times. So I'm still not over the fact that we lost Arecibo. It was such an amazing telescope. I see comments here about Rip Sean Bean in everything he's in. Yes, you cannot have a Sean Bean film or series where Sean Bean does not die. It's just how it happens. Comment from Prathia, I really love how Arecibo is described in the opening of the 2010 Odyssey 2, the book. Yes. Even in the metric age, this was still the 1,000-foot telescope, not the 300-meter telescope. Yeah. It's hugely big. It's 300 meters is big. Again, humans are terrible at distances. 300 meters is like 6 Olympic swimming pools. No, 12 Olympic swimming pools. Math difficult. It's massive. That's a lot of boulders. If you measure things in large boulders the size of small boulders, that's a lot of boulders. It's massive, and I'm still sad that we lost that radio telescope. Anyway, yes, GoldenEye was a great film. I do not remember much of the plot other than it got me interested in radio telescopes, and it got me interested in Arecibo, and Arecibo collapsed. And I was going to say like last year, but apparently it was in December 2020. What is time anyway? Okay, let's see. Comment here from Scott's. I missed a bit. Does this work because all pulsars have the same interval, or we just have good records of periods of each individual pulsar? So the idea here is that you do observations across many years, and then you look for distortions on the time of days or weeks. So, for an example, all of the data that is currently being talked about for pulsar timing array comes from 15 years of observations. So you stare at these pulsars long enough that you kind of predict when you should see the peak in the radio frequency. And then if there's any changes to that, that's what you measure. So it's not the fact that every pulsar behaves the same. In fact, pulsars do not all behave the same. They do not all have the same period, but we record enough of them that we can then do statistics. And you don't just use two, you use multiple. And then the idea is you see how these change with respect to each other. Yes. Coming from Prath, if a pulsar changes its timing, how do they know it's because of changes in time dilation and not because of some matter collapsing into it and changing the rotation? You would need a lot of matter to collapse into a pulsar in order to affect its rotation to the point that it would make a noticeable difference. Now, the thing about pulsar timing arrays, you need to have very good understanding of pulsars, which means you need to have very good understanding of neutron stars, and neutron stars are kind of difficult to understand. They're where did that cat go? Yes, he's there. He's sleeping. Where did the other cat go? Probably sleeping on my pillow. Yeah, so in order to do pulsar timing array, we need pretty good understanding of pulsars. Fortunately, we do have pretty good understanding, but there's still a lot we don't understand about pulsars. So this is something that still requires some effort and some knowledge and some understanding. But pulsars are very cool. And usually we can kind of distinguish if the effect is caused locally in one pulsar or in general. And this is also one of the reasons why we use a network of pulsars, because then if it's just one pulsar that is out of sync, so what's the problem there? But if you have something like a gravitational wave going through, you're going to see this change across multiple pulsars, not just one of them. So then it makes it easier to kind of filter out what is a star problem and what is a space-time issue. Okay, have we found pulsars in other galaxies? I don't think so. I think the problem then comes from the fact that the centers of galaxies are also very radioactive. So measuring the radio waves coming from one star in a distant galaxy is going to be quite hard because we have the overwhelming hum of the center of that galaxy. I'm not 100% sure on that though, so don't quote me on that. But I would say that we have not found pulsars in other galaxies because they are very hard to distinguish from the background. We have found supernovae in other galaxies. I do not think we have found pulsars in other galaxies, but please do not quote me on that. I might be wrong about that. I will check that. Now I'm curious, actually. I will check pulsars in other galaxies. I will add it to my list. The list that is going in the cupboard as soon as this stream is over, and that will not come out again until the next stream. Yes, that is how these things work. This notebook will go away and be forgotten, but I've added it there. So I would say no to pulsars in other galaxies, but please don't quote me on that. Sean Bean, yes. Scott, you're giving spoilers for GoldenEye. You shouldn't give spoilers for a film that is 30 years old. Okay. Coming from Guadav here, there is a pulsar which lies on the outskirts of the Tarantula Nebula in the Large Magellanic Cloud. Okay, that is cool. Huh. So I guess if you have a pulsar that is sufficiently far away from the center of the galaxy, you can potentially distinguish the radio signals. So that makes sense. Thank you for that comment, Gwenaf. It was not in it was not on my mind. But yeah, that sounds cool. That would make sense if you have a pulsar that is sufficiently removed from the center of the galaxy, like on the edges, on the outskirts of the galaxy, that you might be able to find it. So yeah, cool. Pulsars are very, very cool. And we have found a pulsar in the Large Magellanic Cloud. I was not aware of that. That is a very cool thing. Thank you for sharing that, Godaf. Also, as you will see, you just put stats in. I'm like, I believe you. Please don't lie to me. I assume we're all here, truth seekers. God, that sounded so terrible. We're all here because we're interested in finding facts and things and cool things. So if someone says, yeah, there's a pulsar in a nearby galaxy, I'll be like, yeah, I mean, I'm going to fact check you later anyway, but that sounds believable. So that is very cool. Okay. There was one more question I wanted to give a very, very quick fire answer to. Just because some of you said it's your first time catching me live. Also, as always, if I mispronounce any of your names, please do let me know. I just basically take the name that I see here on the YouTube handle and do my best attempt at pronouncing it. If I mispronounce your name, leave me a comment and I will try to take that into consideration for next time. That goes in my brain, that doesn't go on the notebook. I'm not sure which is a more reliable place to put information. Can you tell about research in quantum information and QFT, holographic principal cosmology? Yeah, that's a very vague and very broad question that I'm not going to be able to answer as I want to wrap up the stream. I can say I have done a stream about holography, and I have done a stream about... Did I do a stream about quantum information? I think I did a stream... No, I did a stream about quantum entanglement and its applications to quantum information, and there are streams about holography, and these are in general on the YouTube channel. The holography one is definitely on the YouTube channel. The quantum entanglement one is also on the YouTube channel. QFT is not something I want to touch ever. I have managed to avoid QFT up till now. I will continue to do so. Okay. Whew. Comment here from, but yes, if you have the problem with vague questions like, can you talk about holography, can you talk about cosmology, is that it gives me a lot of things to talk about. So try and ask those questions at the start of the stream, and then I can jump on those topics. Also, just a general comment, I'm not sure if all of you know this because I don't advertise it perhaps as much as I should. There is a way where you can all request a topic, like apart from asking questions here. If you wake up one day and you're like, I want a 90-minute explanation about this specific topic, there's a way you can do that. If you go to the Cup of Cosmology webpage, there's a section of Get Involved, and there you can find information to request a topic. And what I ask is that you do a donation to a charity that matters to me. There's a bunch of different charities listed on the webpage. So if you want to request a topic, and you want to say, like, please do a stream entirely about holography, or do a stream entirely about quark confinement, or a stream about why the forces behave differently at different distances, just throwing out examples here that are on my thing. If you go to Cup of Cosmology webpage, there are instructions, but the key thing is email me first before doing it, because there's some topics that I'm not open to talking about. If you ask me to do a topic praising billionaires, I'm not going to do that, as we've established. So send me an email, contact@cupofcosmology.com. We agree on a topic. Then I ask you to do the donation to the charity that is one of the charities listed on my webpage. And then we arrange a date and I do that topic and I do a stream about that topic. This has happened a couple of times. There have been a couple of streams where I said, today we have this topic requested by this person. So if you have one of these like crazy ideas or vague topics and you're like, I want to know everything there is possibly to know about this patch of the CMB map, get in touch. We can figure it out. I don't advertise this much. I always forget to advertise it. But if you go to cupofcosmology.com, get involved. There's a tab called Get Involved on cupofcosmology.com. And there you can request detailed 90-minute in-depth descriptions of specific topics in exchange for doing a donation to a charity I care about. You can find all the information on the webpage. Okay, final comment. I realize sometimes I never advertise the things I should be advertising. There's also in every YouTube video, there's a link to my Ko-fi page if you want to buy me a coffee. All of that money goes to supporting the cost of maintaining the show, which is basically the web page and the email address, and not much else, and just some basic things that are there. Susie is not on the block list. There's not much on the block list, to be honest. Susie is not on the block list. If you want to request a supersymmetry stream, get in touch. We can figure it out. There is not much on my banned list. There are some things, but there's not a lot on my banned list. And if I don't know how to cover it, I'll get someone else involved as well. So You can request that. Yeah, there's also the Ko-fi link. I know some of you donate occasionally, some of you donate monthly. I appreciate each and every one of you. Thank you so much. Never any obligation to. Cup of Cosmology is and will always be a free stream, because my idea here is that science is cool and everyone should hear about science. I'm not going to charge you for this. Cat is back. I now have one cat to either side of me. Do you have a hair in your mouth? Yeah, me too. You leave hair everywhere. Okay. Oh, don't glare at me. I upset him. Right. Comment here from Press. Speaking of the LMC, I find it pretty mind-blowing that galaxies can orbit galaxies just like moons orbit planets, orbit stars. Yeah, everything in the universe is kind of gravitationally attracted to other things, and then you get things orbiting other things, and you can have stars orbiting moons, and not stars orbiting moons, sorry, moons orbiting stars, moons orbiting planets, which orbit stars, which orbit in a galaxy. Yeah, the universe is weird and crazy and amazing. And we get to try to figure out what it's made of, which is very, very cool. Yeah, Susie is not on the block list. I don't have anything against someone specifically named Susie. You know, Susan, Susie's, you're welcome here. But Susie, as in supersymmetry, that is a topic that I've not really discussed much, but it's not on the banned list. So, you know, get in touch. You can always get in touch. On that note, we've reached the 95-minute mark. This has been great fun. Thank you all for the questions. I always really enjoy it. Again, I say this pretty much every week, but I come here not... Today I didn't have a topic prepared. So I'm like, okay, I have 90 minutes. Let's hope for good questions. Because if you don't ask questions, I'm just going to be here like, okay, here's a CMB map for 90 minutes. You know, I have to improvise. And the fact that you ask enough questions and enough cool questions that we can keep this stream going for 95 minutes is always very cool to me. So thank you everyone for all the comments, for all the questions, for all the discussions. It's been a really fun stream. I've enjoyed hearing all of your perspectives on Mars colonization and space exploration. I've enjoyed the sci-fi recommendations and the questions and the comments. It's always super, super fun. So as always, thank you everyone for being here. I really do appreciate it. Cup of Cosmology will not be online next week because next week is Easter Sunday. And I don't actually celebrate Easter Sunday. Like I'm not an Easter person in general. I do appreciate some of the baked goods around Easter, and I do appreciate the chocolates, but I actually have social plans next Sunday, so I will not be doing a stream. And you know, it's Easter Sunday. I assume a lot of you have plans, so I will not be on the 20th. I do not believe there's nothing in my calendar on the 27th. There should be something in my calendar on the 3rd, and it's not there. Okay, I'll fix that. There's nothing in my calendar for the 27th, which means Cup of Cosmology will be back in 2 weeks on the 27th of April, all being well. No idea what we'll talk about. In the meantime, I will also see if I can find the old spreadsheet with the list of streams. And at some point, I will look into uploading old streams to the YouTube channel, because as we've established here, there's probably about 300 streams that are not on YouTube and that are just sat on a hard drive somewhere. So those would be good to be uploaded at some point. We'll see. I'll think about it. I'll figure out which ones get uploaded, which ones don't. We'll see. Okay, this has been really, really fun. As always, thank you everyone for joining. I really appreciate all of you coming here and chatting and keeping me company on this Sunday evening or afternoon or morning, wherever it is for you. Cup of Cosmology should be back online in 2 weeks. That's April 27th. Same time as always, which is 8 p.m. in Finland, 7 p.m. if you're in mainland Europe, 1 p.m. on the east coast of the US, 10 a.m. on the west coast of the US. As always, there is a time zone converter on cupofcosmology.com where you can figure out when the next stream is in your own time zone. And I have just remembered that the time zone converter is not up to date because I haven't yet accounted for daylight saving time. I will do that immediately right now. Then it will all be fine. Anyway, cupofcosmology.com if you want to get in touch, if you want to see the schedule as usual. Cup of Cosmology will be back in 2 weeks. I hope to see you all then. And I hope in the meantime, you'll take care of each other and stay curious.